class, we discussed about one problem, how to identify stiffness matrix. So, just a recap of what are the formulas we discussed. So, to identify your stiffness matrix, we are going to use this as a formula, which is B transpose D into B, where B is what we call it as a strain displacement matrix. So, it is a relation between strain and displacement. And the B matrix is also mentioned here, which is 1 by 2A of Q1 0, Q2 0, Q3 0, similarly 0 R1, and these are by matrix. And you also know what is the values of this Q1, Q2, Q3, R1, R2, R3, right? After that, you also identify what is by D matrix. D matrix is material property matrix or constitutive matrix. So there are different names in this D matrix. So D matrix, it is considered as two different types. One for a plane stress problem. So your D matrix will be E by 1 minus mu square. So 1 mu 0, mu 1 0, 0 0 1 minus mu by 2. And for plane strain condition, it is different. Your D matrix will be E by 1 plus mu 1 minus 2 mu. So 1 minus mu, mu 0, mu 1 minus mu 0. And this is my matrix. Okay. So this is what we discussed, and if we want to identify a triangle, what is the area of the triangle, irregular shaped triangle, we can use this as a formula. So your area is half of 1 x1 y1, 1 x2 y2, and 1 x3 y3. So if you take determinant and divide by 2, that will give you the area. This is what we discussed. Now we will try to solve one problem related to the CST element. I think, hope we already solved one problem related to identifying stiffness matrix, right? So now we will go for one more, which is dealing with stiffness matrix. So identifying what is the stresses. Let me consider this. You have an element. The element is a plane stress element, and they are given what is the displacements in each of this element after you apply a load. So nodal point 1 is having two displacements. So U1, which is 2 mm, and V1, which is 1 mm. So we can able to see this point. So U1 is 2 mm and V1. So vertical direction, it is 1 mm. So it is mentioned here. Similarly, at nodal point 2, U2 is having 2.5 mm and V2 is having 0. There's no displacement. At point 3, U3 is having 3 mm and V3 you are having 1 mm. So the values are also given. So mu is given. So mu is around 0.25 and thickness is also given. With thickness is 10 mm. The question is you have to identify what is the element stress, right? What is the element stress? And they are also asking what is the principal stress. So to identify your element stress, you no need to identify stiffness matrix. There is no need for finding out the stiffness matrix. So the formula for element stress is D matrix into B matrix into your displacement U. So this is my formula for your stresses to identify the stress of if they have a displacement, right? So to apply this formula, I have to identify two data. What is your D matrix and what is your B matrix? So let us identify what is U matrix. U matrix we already know actually. So it is in terms of U1, V1 other terms. Let me write it out. So your U matrix will be like nodal point 1 will have U1, V1. Nodal point 2 will have U2, V2. And nodal point 3 will have U3, V3. This is my matrix. So which I can write it in a matrix form, in a column. So U1 is 22, V1 is 1, U2 is 0.5, V2 is 0, and U3 is 3, and V3 is 1. So this is my matrix. So when you address it, similar to our elements, so how we will address? We will address as U1, V1, U2, V2, U3, V3. But anyway, we are not going to concentrate on this address because there is no need for addressing it, right? Because we are not going to assemble any of the matrix. We are directly going to substitute it. That's it. Now let us go for B matrix. What is my B matrix? So let me consider this figure. So the formula for B matrix, you know, so B is 1 by 2A, Q1 0, Q2 0, Q3 0, then opposite 0 R1, 0 R2, 0 R3, then cross multiply this. So here you will have R1, this is Q1, R2, Q2, R3, Q3. So you should know what are all these data dot identify your B matrix. First, let us solve one by one. First, let us go for A. What is A? Area of your triangle. How to identify the area of this triangle?
So half into base into height, sir. Base is 60 and height it is 30 minus 120 minus 30, sir, which is 90, sir.
Yeah, very good. So you can directly substitute it, right? Because it's a regular triangle, you can easily identify what is your half and base. So sorry, base and height. So your base is here, which is x-axis coordinate 80 and 20. So 80 minus 20, it is 60. Your height, if I consider my height is y coordinates. So this is 120 and this is 30. So 120 minus 30, so you are getting 90, right? So my height is 90 and my base is 60. So I can identify what is my triangle. So what is the area of the triangle? Area of the triangle is half into base into height, which is equal to half 60 and 90. So we are getting 60 into 90 divided by 2, 2700 mm square. Okay, yeah. So okay, base is we identified this value. This is over. Now I have to identify what is Q1, Q2, Q3, R1, R2, R3. So to identify all the other values. So let me consider this triangle here. This is my triangle. Okay. So there are some points here. So this is my point 1. This is my point 2. This is my point 3. Right. So let me identify what are the coordinate points. So x1, y1. This is x2, y2. And this is x3, y3. And you know what is the coordinate points also. So 20, 30. So 20, 30 here. And this one is 80, 30. And this one is 50, 120. So to identify your value of Q, so let me go for Q value. So Q, as I told you, you go in anti-clockwise direction, right? And concentrate only on Y. Concentrate only on Y. So these two terms you understand. So just remember. So Q always goes in anti-clockwise direction and concentrate only on Y. So if I want Q1, so Q1 is, so other points 2 and 3 moving in anti-clockwise. So Y2 minus Y3, which is I can write as Q1 is equal to 30 minus 120. So we're getting minus 60. Similarly, let me go for Q2. 2 is here. So I'm going in anti-clockwise. So 3 and 1. So Y3 minus Y1. So it is Y3 minus Y1. So Y3 is 120. y1 is 30. So again, this is positive 60. Then Q3, so 1 and 2, so y1 minus y2. So y1 is 30, y2 is also 30, which is equal to 0. So these are my Q1, Q2 and Q3. If I move for R, R is clockwise direction and you have to consider only x coordinates. Okay, so in that case, so what will be the values you will be getting here? R, so R1 clockwise. When I go for clockwise, x3 minus x2. Okay, so x3 minus x2, x3 minus x2. So which is equal to 50 minus 80, which is equal to minus 30. And this is my R1. Next, R2.
Sir, 30
R2.
minus 120, it's minus 90, sir. 120 minus 30, it's 90, sir.
Oh, sorry. This is 90. Okay. Sorry. This two is 90 and 90. So this is 90 and this is also 90. Okay. So this is minus 30 and R2. What is your R2 here? R2 is moving in clockwise. So x1 and x3, right? x1 minus x3. So 20 minus 50, right? Which is minus 30. Next, R3, and I go for R3 again in clockwise. So x2 minus x1. x2 minus x1. So x2 is 80 minus 20. So it is 80 minus 20. So which is equal to 60. Right? Any doubt in this? Finding out your Q and R. Any clarification? Okay, now let us identify what is our B matrix. B. So B matrix is 1 by 2 into 2700. So 1 by 2A, which is already identified, into Q1. Q1 is minus 90, 0. Q2. Q2 is 90, 0. Q3, it is 0, and this also 0. Similarly, 0, R1 minus 30, 0, R2 minus 30, 0, R3, which is 60. So here, just opposite. So minus 30, minus 90, minus 30, 90, 60, and 0. This is my B matrix. So one part is over. Identified our B matrix. The next step is identifying your D matrix. So D matrix. So for D matrix, you have to know what type of element is this. So according to the problem, the element is plane stress element. Okay, so for a plane stress element, you have to concentrate accordingly. So the formula will differ. So your D matrix will be equal to E by 1 minus mu square mu 1 0 0 0 1 minus mu by 2. So note, I may change the symbol accordingly. Actually, this is equal to mu, this mu. Okay, so don't get confused. So this is different and that is different. So otherwise, I will change this here. I hope that will be better. So this is my mu. Okay, so it is 0.25. Let us apply that. So E, what is your E Young's modulus? It is 210 gigapascal. It is mentioned as 210 gigapascal, but it is in Pascal, right? You have to convert it accordingly. So let me consider what is my E value here. It is 210 gigapascal, which is equal to 210 into 10 power 9 Newton per meter square. But we are solving in mm, so which means 210 into 10 power 3 Newton per mm square. Okay, so 1 megapascal is equal to 1 Newton per mm square. So converting like that, you will get this. So you will identify what is the D matrix here. So D matrix will be equal to 210 into 10 power 3 divided by 1 minus mu square. What is your mu square? So 0.25 joule square into 1.25 0 0.25 1 0, right? So 0 0 1 minus 0.25, it is 0.75 divided by 2, just divided by 2. So 0.75 divided by 2, so you're getting 0.3735, right? These are my values. Can you solve and tell me what will be the value for D matrix here? Now what I do, I have to multiply. So as per the value, stress is D into B into U. So first let me multiply DB matrix. Okay, so D matrix, I will write it here. So 2.24 into 10 power 5, right? Into, let me write common term first, then I will multiply the other terms later. Whereas this B matrix, your common term is 1 by 2 into 2700. So this is my common term into B matrix. So D matrix is 1.25 0. So 0.25 1 0 0 0 0.35. What is my B matrix? This is my B matrix, minus 90, minus 90, 0, 90, 0, 0, 0, 0, 30, right? So minus 30, minus 30, and 0, minus 30, 0, 60. And this minus 30, minus 90. So minus 30, 90, 60, 0. These are my terms. Okay, so here also I can take some common terms. So what I can do, I can take the 30 out so that you can minimize a little bit. So you can reduce your work. So what I am going to do is, so let me consider the same thing, same matrix. Only thing is, I am going to take the 30 out. Right, so 30, when I take 30 out, there will be a change in the matrix size. So this will be different. So instead of 90, you will get 3 here, and this will be 1. This will be 2. So 1, minus 1, minus 1, 2. And these things will change accordingly. Right? What will be the value? So it will be minus 3, so minus 1, minus 3, minus 1, 3, 2, 0. So this is my matrix. So now let me write down what is the matrix size now. So this is a 3 cross 3 matrix, and this is 3 cross 6 matrix. right? So in that case, this gets cancelled. So what we'll get is 3 cross 6 matrix. Let me write down what are the terms. So let me identify what is my common term first. So I'm getting around 1244.4. So is my common term. Okay. Into the matrix. Let me multiply it. So this into this, right? So 1 into minus 3. So minus 3. 0.25 into 0, 0 plus 0. 0 into minus 1 plus 0. This is my first term. Next, 1 into 0, 0. So I think I will do it directly. So 1 into 0, 0. 0.25 into minus 1. So minus 0.25. 0 into minus 3, 0. So next, 1 into 3, 3. So this is 3. 0.25 into 0, 0. 0 into minus 1 is also 0. Then 0. So this is minus 25, minus 0.25. Then 0. Next again 0, 0, 0. Last 0, 0.25 into 2, so 0.5. Right? So this is 0. This is entirely 0. So 0.25 into 2 is 0.5. Other things are 0. So 1, 2, 3, 4, 5, 6. Right? So this is my first matrix. Next 0.25 into 3. So what you are getting 0.25 into 3? So you're getting 0.75. So minus 0.75. This is 0 and this is 0. Okay, so 0.25 into 0, 0. So 1 into minus 1, minus 1. 0 into minus 3, 0. So minus 1. 0.25 into 3, again 0.75. Other things are 0. So 0 and 0. Last, again, this is 0, minus 1, 0. So this is minus 1 again. Next. So 0.25 into 0, 0, 0, 0. Everything is 0. Again, 0.25 into this 0. This is 2. I think this is 0. Last 0, 0 minus 0.35. 0, 0, 0.35 into minus. So the thing is, you will be multiplying only this term to. So other things, I think everything. So these two rows will be 0, right? So just multiply that. That will be, you will get the value. Okay, so what you will get? So it is like 0.35 and 0.35 into 3, which is 1. I think minus 1.05, then minus 0.35, and plus 1.05, then 0.70. So this is my matrix. The next step is, let me proceed with multiplying with U matrix. So B, so D, B I multiplied. Now I have to multiply with U. Okay, so I'm going to take the same values. So these things. Now I will multiply this with your U. What is my U? We already identified, right? It is already given in the question. 0.5031 is my matrix. So now let me consider here, this is a 3 into 6 matrix, and this is 6 into 1 matrix. So when I multiply, you will get 3 cross 1 matrix. Okay, so that is your stress, right? So let us identify what is my stress. Stress is equal to, so 3 minus 3 into 2. So this is a common term which is outside. So that will be that I missed. right? So this is the common term which has to be included. So minus 3 into 2 minus 6, 0.25 into 1 minus 0.25, 3 into 0.5, so it is 1.5, so plus 1.5, this into 0, this into this 0, and this is 0.5 plus 0.5, right? Similarly, second one, so minus 3, 7.5 into 2, so it is minus 1.5. Next, um, minus 1 into 1 minus 1, so 0.75 into 0.5. So 0.75 into 0.5 is 0.375. Minus or plus? Plus 0.375. And this is 0. And the next one is also 0. The last one is plus 2. Right? Next. So minus 0.35 into 2. 0.35 into 2, which is 0.7. Minus 0.7. So minus 1.05. So 0.35 into 0.5. So 0.35 into 0.5. We are getting minus 1 point, minus 0.175. This is 0 and 0.7 into 3. 0.7 into 3, you are getting 2.1. So plus 2.1. And the last one is 0. So this is my matrix. So can I add these things and then multiply with 1244.44? What you are getting? Minus 5,288.87. Okay. Next one.
Minus 155.1. Minus 155.55, sir.
155.55. Okay.
233.33, sir.
233.33. So this is nothing but stress in x direction, stress in y direction, and tau, your shear stress. So these are the values. So you have a compressive type of a stress here. Okay, so in x and y directions. Okay, now you have your stress values. So sigma x is known, minus 5288.87. Sigma y is known, which is 155.55. And tau is known, which is 233.33. Now they are asking principal stress. So you know there are two principal stress, sigma 1 and sigma 2. Sigma 1 is nothing but you have a formula, sigma x plus sigma y by 2 plus or minus. So plus means sigma 1, minus means sigma 2. Root of sigma n 1 minus sigma 2 by 2 the whole square plus tau square. So just apply this and identify what is your sigma 1 and sigma 2. 6359.5. Okay. All are in Newton per ounce square. Right. So this completes the problem. So anyway, you try the same type of problem in plane strain condition.